Hi, welcome to this lesson on Euclidean geometry, polygons. Let's have a look at question 4. In the diagram, we have the following information. CD and BE are equal chords, so that's denoted in the diagram. F is a point on the circle, and angle F3 is equal to X. Prove that angle C1 plus C2, which is over here, is equal to angle B1 plus B2, which is this angle here. Okay, so there's quite a lot to unpack there, so let's go line by line with the information and plot as much information as we can on the diagram. Okay, so CD and BE being equal chords means that they subtend equal angles. And in this diagram, BE subtends to the point F at F3, and CD subtends to the point F at angle F1. So this angle must also be equal to X. Okay, so in terms of my proof, I'm going to first off by noting that angle F1 equals angle F3, which equals X, and that is because these are angles subtended by equal chords. Okay, so those angles are equal. What else can I put on here? Well, I've already put angle F3 as X, and F is a point on the circle we've already utilized. So now let's go ahead and see how we can prove that these two angles C1 and C2, when added, are the same as B1 plus B2. So immediately, I notice in this diagram that all the points are on the circumference, and if I look at four lines that are joined together, I can come up with a cyclic quadrilateral. So if I look at, for example, over here, B, C, D, and F, that is a cyclic quadrilateral. And I know some properties about cyclic quadrilaterals, namely that their opposite angles are supplementary. So, because I'm interested in angles C1 and C2, which is both inside this quadrilateral, so I can say in the cyclic quad BCDF, and we know it's cyclic because, again, all four points are on the circumference of the circle, we must have, so this implies, so in cyclic quad BCDF, we have that angle C1 plus angle C2, okay, so this angle here, plus the opposite angle, which is angle F1 plus angle F2, that must give you 180 degrees, because again, opposite angles are supplementary, so they add up to 180 degrees. But if I just group C1 and C2 here together, and I note that angle F1 must be X, and angle F2 is just equal to itself, I now have that equation there. So I'm going to call that equation 1. Next, I'm going to say in the cyclic quad, so I'm going to look at a different one now, a cyclic quad that has angle B1 and B2 in it. So I can say in this cyclic quad here, BCFE. So in cyclic quad BCFE, and again, I know it's cyclic quad because all the points, all the vertices are on the circumference of a circle. I can note then that angle B1 plus angle B2, which I'm going to group together, okay, plus the opposite angle, so angle F3 plus angle F2, that must equal 180 degrees as well. And again, by that same reasoning, opposite angles are supplementary. Okay, but then this must imply that angle B1 plus angle B2 plus angle F3 we know is X, that was given to us, plus angle F2 equals 180 degrees. I'm going to call that equation 2. Now notice that 180 degrees is on the right hand side for both equations, so therefore equation 1 equals equation 2. Therefore, I can say that angle C1 plus C2 plus X plus F2 must be the same as angle B1 plus angle B2 plus angle X plus angle F2. Now notice on the left and the right hand side you have X and F2. So I can subtract both those terms there, and I'm left with angle C1 plus angle C2 equals angle B1 plus angle B2, and that's exactly what we wanted to prove in the first place. So again, how would I go about doing a problem like this? Well, first of all, I would go through the information and I would infer more information from that given information. So for example, here, the fact that we had equal chords, that means they subtended equal angles, and I knew one of the angles already was given to me as X. Okay. And then F being a point on the circle just allowed me to subtend. So I used all the information. The moment you use all the information and everything is done there, then you proceed to look, what else do I have in my geometry toolkit? Well, I have 5 points on the circumference of the circle, and I can see that there are quite a few shapes in here. You could see 3 individual triangles, for example. So maybe we could have done something with similar triangles if we tried to work with those, right? But in this route, what we did is we did cyclic quadrilaterals because we saw that there were 2 of them on this diagram. Okay, and it allowed us to work out angles B1 and B2 and C1 and C2 respectively in an equation, namely these equations here. Okay, so after many hours of practice, when you do lots of these will become more apparent to you as you try more examples. Awesome. I'll see you in the next one.